Hey guys, we're going to start with Eureka, Module 5, Lesson 14. I'm going to walk you through the homework assignment with every question, showing you how to start to set it up. So if you'd like to pause this for each problem, you can. I would like to try and help you so that you're not going through this and struggling. I'm noticing a lot of you still forgetting how to multiply the fractions, how to convert them, or what we're actually looking for, and only sometimes I'm seeing that you're not answering the whole problem. So take this step by step and listen to each problem and then go ahead and solve on your own. You have your workbooks at home that you'll go ahead and write in to do all the math work, but then you will go ahead and put the answers onto the document that we posted into Classroom. All right, so for number one, it says Mr. Albano wants to paint menus on the wall of his cafe in chalkboard paint. The gray area below shows where the rectangular menus will be. Each menu will measure 6 feet wide and 7.5 feet tall. So that means that each of these gray rectangles are the menus. Each of them are going to measure, and what I'm going to do is put down 6 feet wide, and then I'm also going to put down that they are going to be 7.5 feet tall. Each one of these menus are that same measurement, okay? That's what you should do on your paper, to write that out so that you know what each one measures. Now, that's all you have to do for this part. That's just helping prompt you for Part A and Part B. Part A asks, how many square feet of menu space will Mr. Albano have? All right, so we're looking at figuring out the area of this rectangle, this one, and this one. They're all the same measurement. So in order to find area, we're going to take our length times our width and get an answer. Once we get that answer, that is not it, because that's only the area of one of these menus. We have 4 of them. So think about that. Once we do 7.5 times 6, so I'll put that over here. We're going to have to do 7.5 times 6. Once I get my answer, I then have to multiply by a number in order to figure out how much all of the menus take up. Okay, so think about that. So it's a 2-step problem, but one thing to keep in mind, I want to make sure we're multiplying correctly. You guys are forgetting how to multiply a mixed number. You can choose to do it 2 ways. You can choose to say, okay, I've got 7.5, so I can take 7 times 6 and half times 6. So you could do 7 times 6, and that should go in parentheses, plus a half times 6. And I'll put that in parentheses over here. You can choose to do it that way. Or the other way that a lot of you guys said you felt was easiest is to turn that mixed number into an improper fraction. So I'm going to take my denominator, which is 2, and multiply that by my whole number. 2 times 7 is 14. And then I add my numerator. That means that I'm going to have 15 over 2 times 6. This is a little bit easier because you're not having to remember to multiply all of the numbers. It's one step. So now when I have a fraction times a whole number, I take my numerator times my whole number, which 15 times 6, I have to get an answer. And then I'm going to take 2 times 1 because technically 6 is 6 over 1. So it's numerator times numerator, denominator times denominator. You have to solve that for yourself. I'm not going to give you the answer. Once you get that answer for this one menu, now you need to go ahead and figure out how much 4 menus would be. Okay, so then the next step is for B, what is the area of wall space that is not covered by chalkboard paint? Well, they give us the measurement, guys, which is really nice. See up here back at the top, it says 25 feet by 13 2/3 feet. This is the whole wall space that is going to be taking up the space for the menus. It's asking what is the area of wall space that is not covered by chalkboard paint? Not covered. That means whatever area you got for part A, they're not counting that. They're talking about find the area of this whole space, and then what are you going to have to do with the area that you got for the menus then? If we're only looking for the area of the space that's not covered by chalkboard paint, how would I solve for that? Am I going to have to add, subtract, multiply, or divide my answer from part A from my answer that I get from this 25? So in here I would write 25 times 13 and 2/3. I need to figure out what that area is and then either add, subtract, multiply, or divide that answer from part A. Think about it. We're trying to figure out what the space is that's not covered by it. So what do we have to do? Before you go ahead and solve, remember that 13 and 2/3 needs to be converted, or you need to make sure that you're multiplying that whole number. So you're either taking 25 times 13 plus 25 times 2/3. You're either doing it that way, or you're taking 25 times, and now you have to convert 13 and 2/3 into an improper fraction. So we take our denominator times our whole number, and then we add our numerator. So whatever 13 times 3 is, you add 2, and then you put that answer over 3. Okay, so go ahead and try that one out. Okay, moving on to number 2. This problem says Mr. Albano wants to put tiles in the shape of a dinosaur at the front entrance. He will need to cut some tiles in half to make the figure. If each square tile is 4 1/4 inches on each side, what is the total area of the dinosaur? First thing you're going to have to do is figure out how many total square tiles there are. Now, we see these triangles. How many triangles make up one square? Think about it. You're going to have to count these up. You can see that you can see 3 rows of square tiles, but then how many triangles make up one square? Because then however many of those are going to make one whole square, you have to count how many total tiles are there. Once you figure out the total, you're going to have to keep that in mind. It says each square tile is 4 1/4 inches on each side. That means that our length and our width is 4 1/4 inches. In order to find area, we take length times width. That means we're going to take 4 1/4 times 4, and 1/4, and then that's going to give us the area of one tile, just one, which means once you find out the area of one of those tiles, then you have to do something with that answer, whether you're going to add, subtract, multiply, or divide by the amount of total square tiles that you have. Keep in mind, once again, 4 1/4, you might want to keep it that way, or you might want to turn that into an improper fraction. If you don't keep it, it's going to be 4 times 4 plus 4 times 1/4 plus, now here's where we always forget these things. Then we need to do our, once again, we can't forget our 1/4 times 4 and plus our 1/4 times 1/4. So that's a lot to remember because it gets kind of confusing since we're using the same number, and that's where it could get tricky for you guys. Sometimes it's nicer just to turn this into an improper fraction by taking our denominator times our whole number and then adding our numerator. So 4 times 4 plus the 1, getting that answer and putting it over 4. Taking that improper fraction times an improper fraction. Okay? Once you get those improper fractions, all you have to do is numerator times numerator, denominator times denominator. So 4 times 4 is 16, plus 1 is 17 over 4. That means that the other one's going to be 17 over 4. And then we have to go ahead and solve. So it would be 17 times 17 over 4 times 4, whatever those answers are. But remember, once you get that answer, that is not going to be your total answer that we're looking for because the question asks, what is the total area of the dinosaur? That's just one tile. We need to know how much is the area for all of the tiles. Then moving on to number 3. Number 3 is talking about A+ glass, and it's making windows for a new house that is being built. The box shows the list of sizes they must make. Over here, this is the box that they're talking about. The question asks, how many square feet of glass will they need? Well, here is each window size. Each window size. There's 15 windows in this size, and there's 7 windows in this size. Same thing we've been doing, guys. You need to take each measurement, this measurement, length times width, find that area, and then we have to do something. We're going to either add, subtract, multiply, or divide by 15 to figure out the total area of all of these windows. Do the same step with this one. And then if we're looking for that total, then we need to make sure to do what? When we find total, are we going to add or subtract or multiply or divide those numbers? Think about it and solve. Last thing, number 4, Mr. Johnson needs to buy seeds for his backyard lawn. If the lawn measures 40 4/5 feet by 50 7/8 feet, how many square feet of seed will he need to cover the entire area? Well, what do we do to find area? We're going to have to take our length times our width to figure out how much area is needed to seed. The last part down here, this is a tricky one. It's going to ask for 1 bag of seed will cover 500 square feet if he sets his spreader to its highest setting, and 300 square feet if he sets his spreader to the lowest setting. What we're going to have to do is we're going to have to use our answer from part A here, and we're going to have to do something to figure out, we're going to have to use this 500 square feet and do something with that answer. Are we going to add, subtract, multiply, or divide to figure out how many bags of seed? So think about this. If we got our total area and we know how much 1 bag of seed would do, 500 square feet, would I add, subtract, multiply, or divide those numbers to figure out how many total bags I'm going to need in order to cover that? This is a 2-step problem because then it also says if you set it to 300 square feet, if the spreader is set to its lowest setting. So then you're going to have to use that answer again and figure out what 300 square feet would cover. How many bags are you going to need to cover all of that? All right, if you have any questions, let me know.